Hello everyone, welcome to Infinity Learn. My name is Vibhati and I am your physics educator on Infinity Learn. So today's session is lecture number 10 of electric charges and field, and in this chapter we will see what is Gauss's law, right. So before that guys, let me tell you one thing. We have evening and morning batches for you, right, for JEE as well as for NEET, and we have multiple test series for you, and we have doubt learning app, right, doubt solving app. So you can use all this features by applying Vibhati 40 code and you can get 40% off. Okay. So do apply Vibhati 40 code to get 40% off. Let's start with Gauss's law. Okay. It states that the total electric flux through a closed surface is proportional to the total electric charge enclosed within the surface. Okay. Suppose this yellow color is, let's say, imaginary surface, closed surface. Okay. According to Gauss's law, the total flux that is passing through this yellow surface will be directly proportional to the charge inside the surface, charge enclosed by the surface, or you can say that flux phi is directly proportional to charge enclosed, Q enclosed. Okay. So after removing this proportionality sign, you can say that phi is equals to Q enclosed divided by epsilon naught. ठीक है. Flux is also integration E dot dA. तो यहाँ से आप क्या लिख सकते हो? Phi is equals to closed integration E dot dA is equals to Q enclosed divided by epsilon naught. ठीक है. So this is the statement and this is the mathematical representation of Gauss's law. I hope this is clear. ठीक है. This is nothing but the alternate way of Coulomb's law. Coulomb's law और Gauss's law में हम क्या करते हैं? Basically Gauss's law में आप electric field को charge से relate कर सकते हो. Fine, in a different way. So this is nothing new, but we have a different way of relating charge with the electric field. I hope this is clear, right? Now there are certain misconceptions, or you can say that important points जो सारे बच्चों को पता होने चाहिए, so that when you solve some questions based on this law, आपके questions गलत नहीं होंगे. Fine. It states that the total electric flux through a closed surface is proportional to the electric charge enclosed within the surface. This is the statement. Fine. Now look at this diagram. Let's say this is our closed surface. This is our closed surface. Okay. We have 5 charges. Q1, Q2 and Q3 are inside charges, and Q4, Q5 are outside the surface. ठीक है? Hello Nayan. ठीक है? So total charge inside the surface will be Q enclosed. That will be Q1 plus Q2 plus Q3. Fine. And according to Gauss's law, flux will be Q enclosed divided by epsilon naught, and that is Q1 plus Q2 plus Q3 divided by epsilon naught. Fine. Do not include this charges जो कि surface से बाहर हैं. Why? Because अगर मैं Q4 और Q5 को positive consider करूँ, so electric field lines जो होंगी, right, Q4 और Q5 की वजह से basically flux is what? The flow of electric field line through a surface, है ना? Fine. तो Q4 और Q5 की जितनी इलेक्ट्रिक फील्ड लाइंस इस क्लोज्ड सरफेस को एंटर करेंगी, उतनी ही इलेक्ट्रिक फील्ड लाइंस एट द सेम टाइम क्लोज्ड सरफेस को एग्जिट कर जाएंगी. फाइन. सो यू कैन से दैट कि इलेक्ट्रिक फ्लक्स कॉन्ट्रीब्यूशन बाय Q4 0 होगा. वाई? Because incoming flux is equals to outgoing flux, so net flux will be 0. Similarly, Q5 का जो electric flux में contribution होगा, that will be 0. Why? Because incoming flux is equals to outgoing flux. I hope this is clear, right? All right. चलिए now we will use this term very frequently, that is the Gaussian surface, this closed surface जहाँ पे Gauss law is applied, that closed surface is known as Gaussian surface. ठीक है, Gaussian surface is imaginary surface, ऐसा नहीं है कि ये सही में exist करती है, ऐसा नहीं है कि it is made of some material, right? It is your imaginary surface. Over here the spherical surface is Gaussian surface. आप cylindrical surface भी Gaussian surface assume कर सकते हो. Fine. I hope this is clear. ठीक है. Now there are some important points जिस पे हमें बहुत ही ध्यान रखना है. These are the points जहाँ पे mistake होने का chance होता है. First point, if net flux passing through any closed surface is 0, that means phi is 0. E may be 0, but the flux of E must be 0 and the net charge enclosed must be 0. E आपका जो है वो 0 हो भी सकता है, नहीं भी हो सकता. मतलब if any closed surface की बात करें, अगर flux 0 है, E may be 0, but total enclosed charge inside the surface is 0 and the flux due to this E will be 0. Fine. Statement को समझते हैं. Let's decode this statement. Okay. Can you see guys, we have a dipole over here. This is positive charge, this is negative charge, and dipole is nothing but the arrangement of equal and opposite charges separated at a very small distance, right? अब मैं यहाँ पे Gaussian surface assume करती हूँ. Let's assume our Gaussian surface something like this. Okay, fine. So total charge inside the surface will be plus q and minus q. So it will be plus q minus q, that is 0. And because of this, q enclosed will be 0 and q enclosed is 0, then flux will be 0, right? But अगर total charge inside the surface 0 हो जाए, that doesn't mean कि वहाँ पे electric field नहीं होगा. देखो यहाँ पे electric field is present. Can you see this pattern बच्चों? Electric field lines are present. लेकिन इस surface से जितना incoming electric field lines है, उतना ही क्या है? Outgoing electric field lines है. I hope this is clear. ठीक है. Next point is, in Gauss's law, electric field is the net field due to all charges present inside and outside the Gaussian surface. This is very important point. This is very important point, बच्चों. What is the statement of Gauss's law? It is phi is equals to integration E dot dA is equals to Q enclosed divided by epsilon naught. ठीक है. Now look at this statement. In this statement, this electric field is due to the presence of all the charges, ठीक है, inside as well as outside. So this electric field is due to Q1, Q2, Q3, Q4 and Q5. We will include Q1, Q2 and Q3 over here, but while calculating the electric field, you'll have to include all the charges, right? All the charges, Q1, Q2, Q4, Q3 and Q5. I hope this is clear. In Gauss's law, the net flux contributed only by the charges present inside the Gaussian surface. जैसा कि हमने डिस्कस किया बच्चों, Q4 और Q5 का जितना इनकमिंग फ्लक्स है उतना ही क्या हो जाएगा, आउटगोइंग फ्लक्स हो जाएगा, राइट? एंड बिकॉज ऑफ दैट देयर विल बी नो नेट कंट्रीब्यूशन ऑफ आउटसाइड चार्जेस इन द कैलकुलेशन ऑफ इलेक्ट्रिक फ्लक्स. ओके, चलिए बहुत ही बढ़िया. नेक्स्ट इज इफ वी चेंज द कॉन्फ़िगरेशन by displacing the charges inside the Gaussian surface. If you displace this Q1 from here to here, ठीक है, the electric field at any point may change, ठीक है, may change, but the total flux passing through this surface will not change, because total flux depends on what? Total electric charge present inside the surface. It does not depend on the location of the charges, right? So total electric charge will be Q1 plus Q2 plus Q3 only inside the surface, divided by epsilon naught will be your flux. चाहे आप कितना ही charges को displace कर लो, electric field at any point may change because electric field is what? A vector quantity. तो location के साथ आपका electric field का direction और magnitude might change, and because of that at any point the net vector summation of electric fields might change. ठीक है? But आपका जो flux है that will not change because flux does not depend on the location of the charges, it depends on the net charge enclosed in the surface. I hope this is clear. ठीक है? Next is any change in configuration of the charges outside a Gaussian surface. इसको हटा के यहाँ पे ला दो. Fine. Again बच्चों, net charge inside the surface will be constant, that is Q1 plus Q2 plus Q3. So flux remains same. Flux आपका क्या रहेगा? Same रहेगा because we are not changing the magnitude of charges inside the surface. ठीक है? But we are displacing these charges, and electric field is due to all the charges. We are displacing these charges and electric field is calculated due to all the charges present. तो अगर ये charges का location change कर दिया तो ऐसा हो सकता है कि किसी point पे net electric field may change. Fine? Okay? Now let's solve some questions based on all this information. Under what conditions can the electric flux phi E be found through a closed surface? First is if the magnitude of the electric field is known everywhere on the surface. Okay. अगर magnitude of electric field is known everywhere on the surface, तो क्या करेंगे? कुछ भी नहीं. Not required. Second is if the total charge inside the surface is specified, phi is equals to Q enclosed divided by epsilon naught. Yes, total charge inside the surface is specified, so you can calculate the value of flux, है ना? Yes, this will help you. Next is if the total charge outside the surface is specified, नहीं, inside the surface charge चाहिए, outside का कोई काम नहीं है. Only if the location of each point charge inside the surface is specified. Again बच्चों, total flux आपका जो है that will not depend on the location of the charges inside the surface. It will depend on the net magnitude of the charges inside the surface, right? So this will also not help you in finding the value of phi. So correct answer is option B. ठीक है? चलिए. Next is if the flux of electric field through a closed surface is 0, right? Flux of electric field through a closed surface is 0. Then first option, the electric field must be 0 everywhere on the surface. Okay, जैसा कि हमने देखा था in this question. Look at this one. Flux is 0 but electric field is not 0. So first statement is false. It's not true. Second, the total charge inside the surface must be 0. Yes. Why? Because flux is Q enclosed divided by epsilon naught, and if phi is 0, then Q enclosed will be 0. That means total charge inside the surface is 0. है ना? Total charge 0 है. हो सकता है charges present हो, but positive charge और negative charge मिला के क्या हो जाए? 0 हो जाए. Right? So total charge inside the surface must be 0. True. The electric field must be uniform throughout the closed surface. नहीं, ऐसा तो हमने कुछ डिस्कस ही नहीं किया. Phi is equals to Q enclosed upon epsilon naught. बस, ठीक है, इसका भी कोई काम नहीं है. The charge outside the surface must be 0. हाँ, ठीक है, कर लो. हमें काम तो किससे है? Inside the surface से है, right? अगर जब तक inside the surface वाला charge 0 नहीं होगा, total charge, flux will not be 0, right? So again this is useless. So correct option is what? Option B. Next is we have three charges. Q1 is 1 into 10 power minus 6 coulomb, Q2 is 2 into 10 power minus 6 coulomb, and Q3 is minus 3 into 10 power minus 6 coulomb have been placed as shown in the figure. Then the net electric flux will be maximum for the surface. We have three surfaces बच्चों, S1, S2 एंड S3 आपको बताना है कि किस सरफेस के लिए इलेक्ट्रिक फ्लक्स मैक्सिमम होगा, राइट? इलेक्ट्रिक फ्लक्स इज व्हाट? Q enclosed upon epsilon naught is constant. तो फ्लक्स किसके डायरेक्टली प्रोपोर्शनल होगा बच्चों? Q enclosed के, है ना? जिसके पास enclosed चार्ज ज़्यादा होगा, फ्लक्स उसका ज़्यादा होगा. Look at S1. S1 आपका ये सरफेस है, द रेड वाला, रेड बाउंड्री वाला. इसके पास Q2 एंड Q1 चार्जेस हैं. सो Q enclosed फॉर S1 is Q1 plus Q2, that is 1 plus 2 into 10 power minus 6 coulomb. So this is 3 microcoulomb. ठीक है. Next is S2. Look at S2. S2 जो है आपका जो surface है that is this one, yellow boundary वाला. ठीक है. Now net enclosed charge in S2 is Q2 plus Q3. ठीक है. Q2 plus Q3 ध्यान से देखना बच्चों. What is the value of Q2 plus Q3? That is equals to 2 into 10 power minus 6 minus 3 into 10 power minus 6. That is minus 1 into 10 power minus 6 coulomb. Next is S3. आपको बताना है कि S3 से फ्लक्स कितना पास होगा. So S3 is this surface बच्चों, ब्लू बाउंड्री वाला, है ना? सो इसमें टोटल एनक्लोज्ड चार्ज कैन यू कैलकुलेट गाइस? चलिए फटाफट से बताइए व्हाट विल बी द वैल्यू ऑफ टोटल एनक्लोज्ड चार्ज. तीनों चार्जेस इसके अंदर दिख रहे हैं हमें, राइट? सो Q1 प्लस Q2 प्लस Q3 इज द नेट एनक्लोज्ड चार्ज इन S3. दैट इज 1 प्लस 2 माइनस 3 into 10 power minus 6 coulomb. So it will be 0 microcoulomb, right? So maximum magnitude of enclosed charge is through surface S1. फिर किसका है? S2 का. और S3 का क्या है? 0 है. जिसके पास चार्ज अंदर ज़्यादा होगा उससे फ्लक्स ज़्यादा पास करेगा, राइट? सो S1 के पास चार्ज ज़्यादा है तो फ्लक्स थ्रू S1 विल बी मैक्सिमम. करेक्ट आंसर इज ऑप्शन A. Next question is, consider the Gaussian surface that surrounds part of the charge distribution as shown in the figure like this. Then the contribution of the electric field at point P arises from charges Q1 and Q2 only, Q3 and Q4 only, Q1, Q2, Q3 and Q4 and none of the above. ठीक है. Point P पे बच्चों we want to calculate the total electric field. तो भैया जितने चार्जेस हैं उन सब की इलेक्ट्रिक फील्ड लगेगी, है ना? और उसका वेक्टर समीशन विल बी टोटल इलेक्ट्रिक फील्ड. सिंपल है ना? अब देखो अकॉर्डिंग टू गॉसेस लॉ फाई इज इक्वल्स टू इंटीग्रेशन ए डॉट डी ए इज इक्वल्स टू क्यू एनक्लोज्ड डिवाइडेड बाय एप्सिलॉन नॉट. ठीक है. क्यू एनक्लोज्ड इज Q1 प्लस Q2, बट यहाँ पे जो इलेक्ट्रिक फील्ड है दैट इज ड्यू टू ऑल द चार्जेस प्रेजेंट, है ना? कितने चार्जेस है? Q1, Q2, Q3 and Q4. So we have 4 charges. So electric field due to 4 charges will be there. So correct answer is option C, that is Q1, Q2, Q3 and Q4. I hope this is clear, right? चलिए बहुत ही बढ़िया guys, बहुत ही बढ़िया. Next is this one. Charge on an originally uncharged conductor. This conductor is initially uncharged. ठीक है. Is separated by holding a positively charged rod very closely nearby as shown in the figure. So we have a positively charged rod जिस पे प्लस Q चार्ज है, इसको इस अनचार्ज कंडक्टर के पास ले गए. अब क्या होगा? ये अनचार्ज कंडक्टर है, इसमें फ्री इलेक्ट्रॉन्स होंगे. फ्री इलेक्ट्रॉन्स जो हैं इस पॉजिटिव चार्ज को देख के क्या करेंगे? उसकी तरफ भागेंगे. वाई? बिकॉज अनलाइक चार्जेस अट्रैक्ट ईच अदर, राइट? तो यहाँ पे सारे फ्री इलेक्ट्रॉन्स डिपॉजिट हो जाएंगे. इस रीजन में नेगेटिव चार्ज जनरेट हो जाएगा. उसके ऑपोजिट क्या हो जाएगा बच्चों? पॉजिटिव चार्ज डर के दूर भागेगा. उसके ऑपोजिट आपका पॉजिटिव पोलैरिटी डेवलप हो जाएगा. ठीक है, फाइन. बट इलेक्ट्रॉन्स आपका सरफेस छोड़ के नहीं जाएगा. तो जितना नेगेटिव चार्ज यहाँ पे डेवलप हुआ, लेट्स से माइनस क्यू डैश, उतना ही पॉजिटिव चार्ज यहाँ पे डेवलप हो जाएगा प्लस क्यू डैश. ठीक है. आपको बताना है assume that the induced negative charge on the conductor is equal to the positive charge q on the rod. ठीक है, तो बेसिकली माइनस क्यू डैश इज इक्वल्स टू माइनस क्यू एंड ये आपका हो जाएगा प्लस क्यू. फाइन, ठीक है. देन टोटल फ्लक्स थ्रू S1, दिस इज योर गॉसियन सरफेस. ये जो डॉटेड लाइन है दैट इज योर गॉसियन सरफेस. आपको बताना है व्हाट विल बी द टोटल फ्लक्स थ्रू S1. फटाफट से गाइस, नेट एनक्लोज्ड चार्ज देखिए क्या होगा. प्लस क्यू यहाँ डेवलप हुआ, माइनस क्यू यहाँ डेवलप हुआ, and we have plus q over here. So net enclosed charge will be plus q, right? And plus q is net enclosed divided by epsilon naught is equal to what? Flux. तो correct answer आपका क्या आएगा? Option B. Option B is your correct answer. चलिए, बहुत ही बढ़िया. Next is the electric flux from a cube of L is phi. एक क्यूब है जिसका साइड इज L and its electric flux is phi. Fine. अब हमने क्या किया, when the edge of the cube is made double 2L और चार्ज को आधा कर दिया. आपको बताना है what will be the value of new flux. तो आपने edge को डबल कर दिया, size of the cube will increase like this and suppose यहाँ पे अगर enclosed charge Q था तो इस केस में enclosed charge will be Q by 2. Fine. Now according to Gauss's law, Q enclosed divided by epsilon naught is equals to phi. So value of Q will be phi into epsilon naught using first statement. ठीक है. Now in second situation, the size of the cube is doubled. Size से हमें फर्क नहीं पड़ता. We want total enclosed charge. That's it. Total enclosed charge is what? Q by 2. So नया flux phi dash will be Q upon 2 divided by epsilon naught. Q is what? Phi into epsilon naught. तो ये हो जाएगा phi epsilon naught divided by 2 और ये epsilon naught इधर, phi epsilon naught से epsilon naught cancel and phi dash that is the new flux through this new cube will be phi by 2. Correct answer is option C. Basically what is the size of the cube, उससे हमें फ़र्क नहीं पड़ता. We just need Q enclosed. Q enclosed अगर Q है तो फ्लक्स phi हो जाएगा. Q enclosed को आधा किया तो फ्लक्स भी आधा हो जाएगा. Q enclosed को डबल किया तो फ्लक्स will be doubled, right? Because flux is directly proportional to Q enclosed. I hope this is clear, right? So that is it for today's session बच्चों. I'll see you again और बहुत ही सारे PYQs करेंगे in the next session. बट मीन वाइल बच्चों वी आर ऑल्सो अवेलेबल ऑन infinitylearn.com और वहाँ पे बहुत सारे बैचेस चलते हैं फॉर नीट एंड जेई, बहुत सारे टेस्ट सीरीज़ हैं एंड वी आर ऑल्सो अवेलेबल ऑन इन्फिनिटी लर्न डाउट ऐप. वहाँ पे आपके बहुत सारे डाउट्स हम क्लियर करते हैं. सो गाइज यू कैन अप्लाई विभाती 40 कोड टू गेट 40% ऑफ, राइट? सो टेक केयर एवरीवन, बाय बाय.